Equipotential bonding is now a requirement around swimming pools according to the 2005 National Electrical Code. Focusing on the equipotential bond's rebar installation, it's important to understand its specific requirements. The rebar used for the equipotential bond does not need to be raised off the ground using chairs or concrete bricks, unlike typical rebar placement in concrete pours. The key requirement is that the rebar must be in direct contact with the earth for its entire length to effectively perform its bonding function. Also, the rebar needs to be connected to the pool structure and all other metal components located within 5 feet of the pool's inside edge. To further elaborate on the purpose and proper implementation of equipotential bonding around swimming pools, we need to examine the underlying principles of electrical safety and the specific requirements outlined in the National Electrical Code (NEC). The primary goal of equipotential bonding is to minimize voltage gradients in the area surrounding a swimming pool. Voltage gradients occur when electrical current flows through the earth, creating different voltage levels at different points. These voltage differences can pose a shock hazard to individuals in or around the pool. Equipotential bonding aims to create a common electrical potential throughout the pool area, reducing the risk of electric shock. The 2005 National Electrical Code and subsequent editions mandate equipotential bonding to enhance safety near pools. The bonding grid typically consists of a network of conductive materials, including the pool's reinforcing steel, metal components of the pool structure, and a copper conductor grid. These components are interconnected to establish a low impedance path for electrical current. This interconnected network ensures that all metallic parts within the pool area are at approximately the same electrical potential. The NEC specifies which metal components must be bonded. This includes metal parts of the pool structure, such as the reinforcing steel, metal fittings, and any metal ladders or handrails. Additionally, any metal equipment associated with the pool, such as pumps, filters, and heaters, must be bonded. Furthermore, all metal parts within 5 feet horizontally of the inside walls of the pool must be bonded to the equipotential bonding grid. The purpose of bonding these metal components is to prevent voltage differences from developing between them. In the event of an electrical fault, the bonding grid provides a low impedance path for fault current to flow back to the electrical source, tripping the circuit breaker and energizing the circuit. The requirement that the rebar be in contact with the earth for its entire length is crucial for effective equipotential bonding. The earth acts as a conductive medium, helping to distribute electrical potential evenly throughout the pool area. By ensuring that the rebar is in contact with the earth, the bonding grid is effectively grounded, which helps to minimize voltage gradients. The connection of the rebar to the pool structure and other metal components within 5 feet of the pool is equally important. These connections must be made using approved bonding connectors and methods. The bonding connectors should be corrosion resistant and suitable for direct burial in the earth. The connections must be mechanically strong and electrically conductive to ensure a reliable bond. When installing the equipotential bonding grid, it is essential to follow the specific requirements outlined in the NEC. This includes using the correct size and type of conductor, making proper connections, and ensuring that the bonding grid is effectively grounded. It is also important to inspect the bonding grid regularly to ensure that it is in good condition and that all connections are secure. Failure to properly install or maintain the equipotential bonding grid can compromise the safety of the pool area and increase the risk of electric shock. Several factors must be considered for effective equipotential bonding in swimming pools. Firstly, material selection is critical, typically involving copper conductors for their high conductivity and corrosion resistance. The size of the bonding conductors must comply with NEC Table 250.122. Based on the overcurrent protective device rating in the circuit. Secondly, proper installation techniques are crucial, including the use of listed bonding connectors and ensuring all connections are mechanically and electrically sound. Direct burial connections must be suitable for the environment to prevent corrosion. Thirdly, the bonding grid layout should follow a grid pattern around the pool perimeter, ensuring comprehensive coverage. The grid should be connected to all metallic components within the specified zone as defined by the NEC. Fourthly, grounding is essential, as the bonding grid should be connected to the grounding electrode system of the electrical service, as outlined in NEC Article 250. This connection ensures a lower impedance path for fault currents. Fifthly, inspection and testing are necessary to verify the integrity of the bonding system, including visual inspections of connections and continuity testing to confirm low resistance between bonded components. The testing should be conducted during installation and periodically thereafter. For specific scenarios, such as above-ground pulls, the bonding requirements may vary slightly, but the fundamental principle of equipotential bonding remains the same. Above-ground pulls often require bonding of the metal frame and any metal parts within reach of a person in the pool. The connection to the grounding electrode system is also critical for above-ground pulls. Another important consideration is the presence of underground metallic piping systems near the pool. If metallic water pipes or gas pipes are located within the vicinity of the pool, they should also be bonded to the equipotential bonding grid. This helps to prevent voltage differences from developing between the piping systems and the pool structure. In addition to the specific requirements for equipotential bonding, there are also general electrical safety precautions that should be followed around swimming pools. These include maintaining a safe distance between electrical equipment and the pool, using ground fault circuit interrupters (GFCIs) to protect electrical circuits, and avoiding the use of extension cords near the pool. Furthermore, it is important to educate pool users about the dangers of electricity and water. The role of ground fault circuit interrupters is crucial in ensuring electrical safety around swimming pools. GFCIs are designed to detect ground faults, which occur when electrical current leaks to ground. When a ground fault is detected, the GFCI quickly interrupts the flow of electricity, preventing electric shock. The NEC requires GFCIs to be installed on all electrical circuits that serve swimming pools, including outlets, lighting, and equipment. GFCIs should be tested regularly to ensure that they are functioning properly. To further clarify, let's consider a step-by-step approach to installing an equipotential bonding system around a swimming pool following NEC guidelines. Firstly, planning and preparation are essential, including reviewing local codes and obtaining necessary permits. Identify all metallic components within 5 feet of the pool, such as metal fences, lighting fixtures, and pool equipment. Secondly, material acquisition involves gathering the necessary materials, including copper bonding conductors of appropriate size, listed bonding connectors, and grounding clamps. Ensure all materials are corrosion resistant and suitable for direct burial. Thirdly, grid installation requires creating a bonding grid around the pool perimeter. This typically involves burying a copper conductor in the earth, encircling the pool. The conductor should be positioned approximately 3 to 4 feet from the pool's edge. Fourthly, bonding connections involve connecting all identified metallic components to the bonding grid using listed bonding connectors. Ensure connections are mechanically secure and electrically conductive. Fifthly, grounding electrode connection requires connecting the bonding grid to the grounding electrode system, typically a ground rod or grounding plate, as specified in NEC Article 250. Sixthly, inspection and testing involve visually inspecting all connections to ensure they are properly installed and secure. Use a multimeter to perform continuity testing, verifying low resistance between all bonded components. Lastly, documentation and labeling are important, including keeping records of the installation, materials used, and test results. Label the bonding system to indicate its purpose and location. Common mistakes to avoid during equipotential bonding installation include using undersized conductors, which can reduce the effectiveness of the bonding system. Insufficient or improper connections can compromise the integrity of the bonding system. Neglecting to bond all required metallic components can leave gaps in the equipotential plane. Failure to properly ground the bonding system can render it ineffective. Additionally, ignoring local codes and regulations can result in non-compliance and potential safety hazards. The importance of regular maintenance and inspection of the equipotential bonding system cannot be overstated. Periodic inspections should be conducted to check for corrosion, loose connections, and damage to conductors. Testing the continuity of the bonding system can help identify potential problems early on. Any issues discovered during inspection should be promptly addressed to maintain the effectiveness of the bonding system. Furthermore, consider the impact of pool renovations or modifications on the equipotential bonding system. Any changes to the pool structure or surrounding area may require adjustments to the bonding system to ensure continued compliance with the NEC. It is essential to consult with a qualified electrician when making any modifications to the pool or its electrical system. The use of exothermic welding for bonding connections offers several advantages. Exothermic welds create a permanent, low-resistance connection that is highly resistant to corrosion. This method is often used for critical bonding connections such as those between the bonding grid and the grounding electrode system. However, exothermic welding requires specialized equipment and training and should only be performed by qualified personnel. Addressing frequently asked questions about equipotential bonding can help clarify common misunderstandings. For instance, does equipotential bonding eliminate the risk of electric shock entirely? While equipotential bonding significantly reduces the risk of electric shock, it does not eliminate it completely. It is still important to follow all electrical safety precautions around swimming pools. Another question is, can I install the equipotential bonding system myself? It is recommended to hire a qualified electrician to install the equipotential bonding system to ensure that it is done correctly and in compliance with the NEC. What are the consequences of not having an equipotential bonding system? Failure to have an equipotential bonding system can increase the risk of electric shock and may also violate local codes and regulations. Finally, how often should I inspect and test the equipotential bonding system? It is recommended to inspect the bonding system annually and test it every few years to ensure that it is functioning properly. In summary, equipotential bonding is a critical safety measure for swimming pools. By understanding the principles of equipotential bonding and following the requirements of the NEC, you can help to ensure the safety of pool users and prevent electric shock hazards.